So the resistors have to be fabricated in such a way that they should overcome these noises when these resistors are going to be present in the receiver side. So for that only we have special type of resistors which are fabricated, which will have a very small amount of excess noise. For example, you have carbon composition resistors. So these resistances are made up of a special type of films which will ensure that even if a DC current is going through the resistance, the RMS value of flicker noise is going to be minimal. And also we have metal film resistor, we have wire wound resistors. These resistors also have smallest amount of excess noise. See, generally all resistors are carbon composition cases resistors which are offenders, which mean that they are going to have large amount of flicker noise. So you can replace this carbon composition resistors by metal film resistors and wire wound resistors, which will exhibit small amount of excess noise or flicker noise. So you can never make this noise zero. Only way to minimize the flicker noise in resistor is to use a special mechanism to fabricate the already existing resistances. That is by using the metal film resistance and wire wound resistance, which are going to possess a very limited amount of excess noise. So why the carbon composition resistance are going to have a large amount of noise means carbon composition resistors are made up of carbon, and you know these carbon molecules will have a bond between them, and that is going to form a micro arc. So this random formation of micro arc will in turn trigger the current flow, which will in turn increase the noise. So that is the reason why carbon composition resistors are producing very high amount of flicker noise. But the same carbon composition resistors, if they are modified into carbon film resistors, they exhibit less excess noise. The only thing, the fabrication methodology is going to change. Our ultimate goal is to minimize flicker noise. So if I use the conventional carbon composition resistors, the noise is going to be very large. So I cannot, carbon is available cheaply. So I cannot replace carbon by a high cost molecule, right? So I'm going to retain the carbon. I'm going to change the methodology to carbon film resistors, which will ensure that the excess noise is going to be minimal. Even if a DC current is going to flow, it will have a minimal excess noise produced from the resistors. So we have an expression which shows the dependence of noise on various parameters. So this is the RMS noise voltage for a carbon composition resistors, or you can say it is for a resistor which is fabricated to have minimal amount of flicker noise. So the RMS voltage is given by K by F, R square by A, V square delta F. You know K is an empirical device specific parameter, and the K value is 10 power minus 28 for diffuse and ion implanted resistors. So this K value will depend on what fabrication method you are going to follow. Whereas for thick film resistors, the K value is even more larger. It is completely opposite. See, the noise voltage is proportional to K. For ion implanted resistors, the K value is almost zero. But for a thick film resistor, the K value is very much larger. And R, you know, it is the sheet resistivity. A is going to be your area of the resistor, and V square V is going to be the voltage across the resistor. Okay, so this expression will clearly say what is the RMS noise voltage generated by flicker noise in the different types of resistors.